Meredith Moore is the founder of Ouroboros Deconstruction, a Toronto-based company working to recover and rehome building materials before they become waste. With over 30 projects completed and a 90% landfill diversion rate, that's amazing. Her work spans salvage audits, hands-on deconstruction, and the development of local reuse systems that keep quality materials in circulation. She also leads Ouroboros Salvage, a registered charity focused on material recovery and community engagement. An interior designer by trade, Meredith previously served as a founding director of the Healthy Materials Library at Parsons School of Design, working to make material health information more accessible across the design and construction industries. So Meredith's talk is going to be Beyond the Envelope, Embodied Carbon, and the Case for Deconstruction. I know everyone here is very excited to hear all about this, Meredith, so please go right ahead.
Awesome. Okay, this is what we want. Can everyone see that? Are we live? Awesome. Okay, so thank you for the wonderful introduction. I'm Meredith Moore, founder of Ouroboros Deconstruction in Toronto, and we take buildings apart. Most people think that that's pretty much the bulk of our work and the most interesting thing, but over the last few years, I've become much more interested in really what's happening outside of the deconstruction, what's happening before and after this slow demolition process. What gets saved, what's getting thrown away, and what happens to all of the material and value already embedded within our existing buildings. So I was excited to speak with everyone today because the Passive House movement has done so much to advance the conversation around building performance and operational carbon. And tonight I want to reframe it a little bit, and I want to talk about a different piece of the puzzle, the embodied carbon, material reuse, and the hidden afterlife of buildings. Before I ever worked on a job site, I studied history of art and architecture. So this is my slightly dramatic self-portrait and opening slide. It's a reference to Christina's World, which, if you're not familiar, it's an Andrew Wyeth painting. And it's about longing. And she's longing for a house and for a family. But in my version, I'm thinking about the house and I'm thinking about what it's made of. Because once you start to understand how buildings are assembled, you start to really see a blind spot at the end of their life. So we all know we have a little bit of a problem when it comes to demolition. Commercial demolition is one thing. Residential demolition, which our firm specializes in, is completely different. And in Toronto alone, I think there are about 2,700 residential permits that are pulled each year. And we know, as everyone who works in the industry, those are the permits that are pulled. A lot of work gets done without permits. So to put that into perspective, a single 2,000 square foot home can generate about 140,000 pounds of waste. And much of that is perfectly reusable wood, brick, and other finishes and fixtures. And that's 140,000 pounds of waste is equivalent to about how much one person will produce in their entire lifetime. And while we often focus on the carbon associated with new construction, each demolition project that gets us to that new construction really represents the loss of materials, the labor, the energy, all of this embodied carbon that was invested in the building originally. And this volume of waste, it's not just economic value, it's also it's a missed opportunity, and it's really requiring us to use more virgin material. I think everyone's familiar with this kind of graphic at this point, but most of our industry, we're really focused on the bottom half of the diagram. We want to build efficiently. We've become really good at reducing our operational energy. But really the greatest opportunity often sits at the top. It's building nothing, which we know we can't do, building less, which also not really possible right now, and reuse what already exists, which people are trying to do, but we know that's also very difficult. But so this is kind of where our work begins. So this is a video of our crew. This is from a project that I'm going to talk about a little bit later, but it's a time lapse of a full building deconstruction. And this is how buildings used to be taken apart when materials had value. And then machines got faster, landfill got cheaper, and demolition became the default. Deconstruction is really an attempt to reverse that equation. It's not just about taking buildings apart, it's about figuring out what happens to everything inside of them. So I started Ouroboros in 2022 with these ideas and with creating a full circle approach to material recovery. And I like the Ouroboros because it's a great example. It's an emblem for what our company does, this continuous cycle of destruction and recreation. So at Ouroboros, our goal is really simple. We want to make deconstruction cost effective and accessible, and we're aiming to change the way demolition is conducted so that materials are salvaged and widely available as a resource within the community. In our work, reuse can't be an afterthought. It has to be considered from the beginning of the process. We started out primarily doing interior deconstructions, kind of for full guts. Now we've gone on and we've expanded our services to include audits, recovery, material sales, consulting. And it really just goes to show that taking the building apart is just kind of the beginning of the whole process. These are a few of our residential projects. We've completed over 40 at this point. We've had a very busy spring, which is great. And as mentioned, we achieve on average about a 90% diversion rate. And more recently, we've started to expand into commercial and institutional projects. Larger buildings, we've learned, just really means more paperwork on our side. So to give you a better understanding of our process and how all of this really comes together, I want to do a quick walkthrough of a project we did in partnership with Create.to in the city of Toronto. This became Toronto's first municipally supported deconstruction pilot, and it became a chance for us to test how material recovery could support broader climate goals. So this wasn't a very big house. It was about 1,600 square feet. 40 plus families lived here over the 140 years that it stood. And it only cost $2,400 to build, which is pretty incredible when it was built in 1884. The project involved an incredible network of partners across heritage, engineering, carbon, accounting, recycling, and material reuse. And all of our projects start the same way. We begin with an audit where we document what exists, what we can recover, and where it all needs to go. And the audit becomes the foundation for everything that follows. Once the audit's complete, we begin the interior strip. That's when we go in and we remove all of our finishes and fixtures. Then any abatement that needs to happen goes through our trained team. After that, we move into the wall layers, the drywall, or in this case, the plaster and lath, and then the installation. And because we're taking the building apart in stages, we're able to achieve a much higher recycling rate than you would if it was being done with a machine. And then once all those layers are removed, the structure becomes visible. And once the structure is exposed, the building starts telling stories. We start to uncover notes and other things, and we're really able to see the lumber package that it was built with. We worked with a gentleman, Zachary Malika, who did a bunch of point cloud studies. So this is a photogrammetry study that was generated from over 1,200 photographs. And we were playing around with trying to determine how much we could push the idea of figuring out the lumber package prior to really getting to this point, how much we could anticipate and estimate versus what we would actually have. So once the structure is exposed, we work our way down from the roof. Materials are sorted, they're processed, and evaluated in real time. Unfortunately, we can't keep everything, and I'm truly a bit of a material hoarder. So if we could, I would, but ultimately the market and our infrastructure are what make those decisions at this point. So any lumber that's a complex assemblage, any spray foam that might have touched stuff, if we know that it's under 6 feet, for the most part, that's all getting recycled. The materials are really the driver for all of this and why I got into deconstruction in the first place. Once the buildings come apart, you start to see the actual materials that the city's made from, the old growth lumber, the handmade brick, the millwork. And these materials are often difficult or impossible to source today, and we're currently treating them as waste. They're going to bins, they're going to the landfill, and it's really just a loss. So in our work, one thing that people always asks is where does all this material end up when you're done with these projects? And the answer is everywhere. We have created an incredible network and done a lot of legwork to find secondary markets, people that we know will take this material. For anyone who doesn't know, drywall is infinitely recyclable. And so there's a great facility outside of Toronto in Oakville, but they're throughout Canada. And I always plug the idea that everyone should be recycling their drywall so that we're not mining for gypsum. These are the metrics and the data that everyone is so interested in, and they really do matter. We know we had 49.5 metric tons of CO2e avoided carbon from this deconstruction. We recovered over 12,000 board feet of lumber. We employed, I think on this project, an average of 7 people on site daily for the 17 days we were on site. So that was the equivalent of 627 labor hours that we were providing low barrier trade opportunities for people to come in and work. And we diverted 55 metric tons of material from the landfill. So all of these statistics matter, and we know this is important. But I'm increasingly interested in what they don't capture. You know, what is the value of the material, the craftsmanship, and the value of extending the service life of these materials? Deconstruction is definitely slower. There's no way I can say that we move as fast as one person in an excavator, but it also creates more jobs, more value, and more opportunity to keep these materials in circulation. We do a lot of documentation around our work so that we can gather data, so that we have a better understanding of material mapping for future projects. And without this documentation, this is really just careful demolition or slow demolition, as we've been told. But with documentation, reuse becomes measurable and scalable. And for this project with the city, it becomes data points for them to start to think about how certain deconstruction measures and mandates could be put in farther down the road. Even when we do all this documentation, when we start to do the carbon accounting, we're finding out that these systems are still catching up. Most carbon tools are built around contemporary products, new manufacturing processes, and relatively linear material cycles. But it's really difficult, you know, how are we accounting for materials that were produced in 1884 using entirely different extraction and manufacturing systems than the ones that our databases are currently built around? And it's really difficult to kind of wrap your head around old growth lumber from trees that may have grown for centuries before they were harvested, and then they remained in service for another 140 years, and now we're putting them back into buildings. So current LCA frameworks can capture parts of the story, but they still are really struggling to represent the complexity of these historic materials that have already existed through multiple generations of use. And I don't think that the point is the accounting is wrong. It's that these materials, they just don't fit neatly into the frameworks that we currently have designed around contemporary products and this relatively linear life cycle. And so for us, you know, we often feel like it's not, the math just isn't adding up for us. We had a heated debate with someone who basically told us that if we were to reuse salvage lumber, and if it underwent certain processing methods, you know, if we were to use pneumatic tools versus doing it by hand, then actually from a carbon perspective, we would be better off using virgin lumber. And he had done all the math behind it, but it just, you know, like, it just doesn't quite make sense right now for us. So we've talked a little bit about how we recover and we document the materials, but material is really only truly recovered if it has somewhere to go. Otherwise, it's just delayed waste on our side. And this is where the work becomes more than just a single building or a house that we've deconstructed. Recovering materials is hard, the deconstruction is hard, but finding these reliable pathways back into reuse, we've realized is actually the harder part. So we've spent, this is really where we're throwing our energy now that we've built up a great deconstruction pipeline of work. Now it's really determining where all these materials going back into the economy. So under current building codes in Ontario, salvage lumber has to be regraded for it to be reused structurally. And while some of this lumber, a lot of this lumber is really too beautiful to hide back into walls, structural reuse is the most scalable and impactful pathway forward for us. We've done 6 regrading processes, all for smaller ADU laneway suites. And for our first project, we documented the full process from deconstruction to grading to installation. ECCC funded a case study documenting the process, which is available online for reference. But basically, we deconstructed a home. Joists that were taken from one home were then taken to our warehouse. They were processed. A Canadian softwood inspector came in, an engineer came in, and then they were put back into a lumber package for structural reuse. Not every material returns to construction. Some become products, furniture, and finishes, and we're really appreciative of the designers and makers that we get to work with, because nothing's better than walking into a restaurant and knowing that you're surrounded by all of your old growth timber that you've sold to them. Local Inventory is our new in-house furniture brand, and it came from the realization that recovery just wasn't enough. These materials needed markets. And so we built this furniture brand with designer Daniel Gruder with the ideas of convenience, affordability, and modern design in mind. It's all flat pack furniture. You're able to designate the level of finish that you want on it, and it's available at a price point that most people can afford. We've also been exploring with salvaged dimensional lumber to see how it can be integrated into NLT panels. And what's especially exciting about this process for us is by far what takes the longest is processing this lumber, removing all of the metal fasteners. And so we're looking at compression techniques where we would be able to leave a certain amount of the metal fasteners in the wood, compress it, and then those existing metal fasteners would act as joiners for the NLT panels. And this is great because it's a like structural regrading structural lumber. We're looking at ways to get it back into the structure, and we're treating it not as a niche material, but starting to really think about it operating at the scale of modern construction. The exciting thing for us is that while we're one of the only deconstruction service providers in Southern Ontario, this isn't a fringe conversation. This isn't something that just a few of us are doing in North America. We're really starting to see this movement grow, and we're starting to see more municipalities and provinces start to take a stance on it. In Toronto, embodied carbon is now part of the Toronto Green Standard, which means the industry is already starting to shift into seeing the importance of this kind of work. And while we're excited and we're seeing a lot of momentum around deconstruction and reuse, there's still some very practical barriers that keep coming up for us. By far, infrastructure, storage, warehousing space is the biggest issue we have. We operate in downtown Toronto, and with the idea that we want to keep our materials close to the community in which we took them out of, it's expensive to find industrial space, which is also disappearing pretty quickly. Finding reliable recycling partners. Recycling is a commodity, and so every project we have to check with our teams that we work with to make sure that they're accepting that material. And if we're working on a project farther away, then we have to basically build new teams for these projects. In Toronto, which I think most of Canada, we do not have any type of policy or incentives around deconstruction and material reuse. So we are going up against demolition companies that are faster and much less expensive sometimes. And so it's not really a level playing field. And small levers that could be pushed and pulled would really help this industry grow. And then I think there's still quite a problem surrounding the perception of these materials. Salvage material is seen as rustic or niche or very much secondary than a resource that we have that's valuable in the construction industry. But back on a happy note, we have 2 warehouses in downtown Toronto now. We have one on Queens Quay East, one on Knox Avenue in Leslieville. And for me, they represent something much bigger than storage. Through partnerships with developers and property owners, we've started to create spaces where these recovered materials can remain in circulation, where we can get people in to see them, to see the opportunities, to see the beauty of them, and have a place to process them and store them long enough for them actually to get reused. And my hope is that over time, this becomes much larger than a single warehouse or company. We see, we're hoping that this starts to really take off and that these are community resources that are available, multiple places within a city. It's not just you have to come down to Ouroboros' shop to find this. But the more time we spend in this industry and recovering materials, the more obvious it becomes that the biggest challenge is really space. And cities already have massive infrastructure dedicated to material removal and disposal. We call it waste management. The question is how we begin shifting parts of that infrastructure toward recovery and reuse instead. And that really starts to raise larger urban questions, but I think those are ones that we need to start addressing. Because this isn't about just one house. Ontario, like many other provinces, is running out of landfill space. We ship a lot of stuff down to Michigan. Tariffs were just raised. A new landfill costs about between 400 and 800 million to build. And a small amount of that could be diverted to circular initiatives. And I think we would see an incredible uptick in what could be done with that. So we can either build new landfills or we can build reuse infrastructure and thrive from the economy that surrounds it. So at its core, our work is about seeing buildings differently, not as waste, but as resources already filled with material, labor, and value. And I always put this out there because people generally are interested in wanting to know what they can do. So if you're in design, specify salvage. If you're in policy, rethink permitting. If you're in engineering, rethink grading and certification. If you're in architecture and design, think about design for disassembly. Anyone and everyone can get involved, and this field really needs all of us. So if you're in Southern Ontario, please come visit our yard, come see our salvage studio, and come get your hands dirty. Thank you.